Hey there, YouTube. Welcome to the Daily Space Weather. I'm your host, Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. And today we're looking at magnetosphere movies, all three of them: velocity, density, and pressure. We've got some high velocity zones as plasma gets reintegrated into this solar wind. That's the velocity over the past 4 hours, and we've got a very diffuse solar wind. That's why we're showing all three frames today. It's all based on the space weather modeling framework. So there's velocity over the past 4 hours. Here is density. This is protons per cubic centimeter. Keep in mind the scale here is only 0 to 4 protons per cubic centimeter, and it's showing high density regions in dark blue, low density regions in white. Again, we've got a very diffuse solar wind here. And you can see it coming in there, how diffuse it indeed is, and the plasma environment diffuse around the planet in its entirety. So that's 4 hours of density. And last but not least, here's 4 hours of pressure. We usually only show the pressure, but when we see extreme events, it's sometimes optimal to show all three. So a very low pressure environment here. The most pressure is on the dark side of the planet, the non-sun side, the side that includes the magnetotail. Anyway, again, that's the last 4 hours. If you want to read more about the Space Weather Modeling Framework, click on the Details tab. It'll give you a link to the Space Weather Modeling Framework. Very low pressure. Next, we'll look at ground magnetic perturbations. Geospace Delta B changes to Earth's B field. And not a whole lot of changes going on to Earth's B field at the moment. You'll see this light up during periods of geomagnetic storm and geomagnetic unrest. We'll also be covering coronal holes and sunspots and how to forecast using magnetic data. Next, the planetary K index, a measurement of global geomagnetism at 2. KP2 is the current situation. It is a geomagnetic calm scenario. Next, the real-time solar wind. Again, we've got a very diffuse solar wind here, barely at around 1 proton per cubic centimeter, to the point where error bars are showing up. Looks like a fairly legit signal, though. I'm going to say solar wind density 1 proton per cubic centimeter. Again, very dense. The speed isn't all that low here, although, so the speed is at 390 kilometers per second. But again, very diffuse solar wind at a sort of a background level solar wind speed. And let's talk about magnetism. So here are the GOES magnetometers for the past 3 days. The GOES magnetometers are at a geosynchronous near equatorial orbit. The N's and M's stand for noon and midnight local time for the satellites. And it looks like the GOES 17 had to adjust its orbit a little bit. Those arcjet moments are the turning on of the thrusters. And let's talk about the GONG 2 data. So the GONG 2 data, what's interesting about this, first of all, the Earth is going to snap into a North Pole current sheet in the coming hours, we would expect. You can see the North Pole current sheet shown here in green, South Pole current shown here in red. That's the heliospheric current sheet. There are two main current sheets. They're associated with being oriented to either polar field. And the way we can forecast solar activity with this is, well, it'll be more evident on the next slide. But what happens is, if you've got a sunspot in the southern hemisphere, the northern current sheet is more likely to come through. If you've got sunspots in the southern hemisphere, if you've got sunspots in the northern hemisphere, the South Pole current sheet is more likely to come through, and it'll be more evident in the next slide. So this is part of the reason why this is such a good forecasting tool. And if you immerse yourself in the data, folks, it's one of the many ways that in the realm of science, you find yourself asking questions about nature and obtaining answers to questions not asked. So that's what's happened on the channel. We weren't expecting to be able to explain the mechanism underlying the solar cycles either, but that's just a thing that happens. So looking at the line of sight ecliptic plane field plot, you can see this blue line. That's a reference to basically to the BZ in the solar wind data. It's giving us insight into the vertical component of the sun's magnetic field. And so when you see sunspots down here, you'll see this get pulled way down to the south, which will expose the North Pole current sheet. And that's sort of how it works. It may seem counterintuitive. If you've got activity in the south, you can expect a North Pole current sheet. If you've got activity in the north, you can expect a South Pole current sheet. That's for you Sugas shenanigans. Our pal from Germany. Germany, a country that I visited. That everything ist bigger, yeah? Just kidding. I love Germany. It's fantastic. I was also to Austria when I visited the high point of the country, the Zugspitze, which straddles the Germany-Austria border. Next, the line of sight coronal hole plot. Looking at coronal holes here to see some pretty well-defined ones looking like they're rotating in here in the northeast. So you can see that those green areas there, those are North Pole oriented coronal holes. The Sun's B field shown here in blue. North Pole current sheet should be here at any moment, if not already. So here's a visual analysis of it in 193 angstroms ionized iron from the SDO, the Solar Dynamics Observatory. I think it's my favorite telescope. Let us know in the comments what your favorite telescope is. Is it the James Webb? Is it the Hubble? I think mine is the SDO. So who knows? Maybe that'll change. It all depends on what the James Webb is looking at in the near future. In the infrared spectrum, this is part of the ultraviolet spectrum. And we can expect those coronal holes in the northeast to become a little more well-defined in the coming days. Let's move on to sunspots. And they're pretty significant in the southern hemisphere. We've seen quite a few flares from them, especially sunspot 3004. That is the current area to watch, especially. 3006 also remains beta class. They're both capable of producing some major flares. We'll see what happens. And you see the likelihood of flares has gone up here a little bit throughout the past 24 hours. Don't be surprised to see some major flares and some earthly-oriented coronal mass ejections. So here's the closest star in 1700 angstroms. Spectacular imagery here of a bunch of sunspots in the southern hemisphere. How about a close-up? And that's 3004, right? Okay, sunspot 3004. It's grown a little bit there. It's consolidated its leading umbra, gotten a little bit bigger, and it is still quite a capable sunspot there, folks. Certainly capable of producing major flares, and so is sunspot 3006. The rest of these are alpha-class sunspots, folks. Sunspots that are a little bit less magnetically complex, less likely to produce major flares. We'll also show some additional close-ups of that in just a moment. First, I would remind our viewers that we've been doing daily space weather videos for like 5 years at this point. If you're interested in what was going on in the sun years ago, there are over 1,000 videos, pushing 1,200 videos in our daily space weather videos playlist. So check out our playlists. There are also music videos. So many daily space weather videos, yes. Because again, in the realm of science, we ask questions, and sometimes we receive answers to questions not asked, which is just a weird thing that often happens. Oftentimes, folks, we ask questions in science, and we end up with no answers at all, and just more questions. Other times we end up with weird answers, and it's just the way it works. So yeah, check out our playlists. You'll find music videos, meteorology segments, all kinds of stuff that it may or may not be associated with space weather. But as you can see, quite a few daily space weather videos. And we pride ourselves on making good thumbnails and some amusing content now and then. So thanks to our YouTube subscribers. And I would remind each of you that our finest days lie ahead. Have you answered our Twitter poll yet? On April 30th, we put up a Twitter poll. We want to know what you think, whether or not Twitter is, quote, fixed, end quote. So make sure you hit us up on Twitter and answer that poll. Again, it's from April 30th. Just scroll down at twitter.com/smashamash and respond to that. It's the final day, only 23 hours left. And no matter how desperate things get, folks, please don't pole vault the caldera. It could be unhealthful. We don't want to breathe you in, and we don't want you to become part of the lithosphere by being integrated into a lava lake. We do want you to have some stylish gear for the summertime, so perhaps pick up some. You can find links at smashamash.com as well as below this video. If you're going through hell, keep going. That's a quote from Winston Churchill. Number 1, I order you to not take a number 2 in your pants. Engage. And do not pole vault the caldera. This public service message brought to you at massive personal risk and expense by Smash staff and I, so give her a raise by picking up some merch. We're also on BitChute thanks to our 700th subscriber. Thanks to all of our subscribers on BitChute. Thanks to our Twitch followers. If you're a larger channel, please host us on Twitch. We streamed for 11 hours yesterday. Shout out again to our Twitch followers. Thanks for tuning in. And shout out to the Smash team. We replaced Patreon with a superior website, although we still are on Patreon. Smashamash.com/Smash Team. Gold and silver subscribers get GDAX daily disaster reports and a lot more, which we can't tell you about because you'd have to be a gold or silver subscriber. You can find links to all of that at smashamash.com, our Redbubble shop. We're still on Patreon. Again, give Smash staff a raise by donating to the cause. You can also find our Facebook group, a permanent invite to our Discord chat. And welcome to the Neo Renaissance. Congratulations on realizing we exist. Take a moment to press like and subscribe if you enjoy the content. This video is a YouTube exclusive, although we will have made 3 daily space weather videos by the time you saw this one. Let's get back to the data, like the GOES proton flux. So there it is over the past 3 days, flatlined. None of those flares have produced any relativistic particles that have reached Earth, at least. And there's the GOES X-ray flux. You can see a double M-class flare happening here between the hours of 1310 and 1410 yesterday. So 1 hour, 2 M-class flares. And we're back to sort of a C background level here. A little bit of a reduction in solar activity since yesterday. The radio flux now at 120 solar flux units. If you're wondering what the radio flux is, it's the most proportional data set to sunspot number. And a solar flux unit is equivalent to 10,000 joules of radio flux density. Now we're looking at 131 and 94 angstroms combined. This composite imagery, courtesy of the Solar Dynamics Observatory. Again, there are 2 M-class flares in there. I think they're from Sunspot 3004. And we've also included composite imagery at 304 and 171 angstroms. Huge filaments also in the southern hemisphere. Don't be surprised to see an Earth-directed coronal mass ejection, or at least in the Earth vicinity. In fact, I'm sort of counting on it. We can expect to see some coronal mass ejections in the coming day or days. I'll just leave it there, and I won't even explain how the forecasting occurs. I will bring up a star chart, though. Mine faces the south as I'm facing the south. The ecliptic is to the south for everybody in the northern hemisphere. That's the path the sun will take across the sky, depicted here in the yellow line. The blue line is the galactic plane. Planetary pileup continues each morning with Saturn, Mars, Jupiter, and Venus rising ahead of the closest star. Here is a solar system forecast. We've got a crescent waxing. There's where things will be in a week. Mercury swinging past the rest of we planets. And we'll close things out with some coronagraph imagery. Stereo A is back on the Integrated Space Weather Analysis Center. It's located at Lagrange Point 5, and it'll be on the left of your screen. On the right of your screen, you'll see the Soho-Lascaux C3. There was a minor coronal mass ejection here. We don't expect that to be anywhere near the Earth. It's sort of on the opposite side of the sun entirely. And from the perspective of Stereo A, for you new viewers out there, Earth would be off on this line. Again, to show you the diagram here, that's where Stereo A is located. It trails Earth, orbitally speaking. So we do expect to see additional coronal mass ejections here. They may be earthly directed. It's too early to tell. But I would say in the next 24 to 36 hours, we can see some CMEs in the earthly vicinity at least. That's about where we have to close things out. So thanks for tuning in, everybody, on YouTube. Congratulations on realizing the channel exists. We'll see you next time at the Smash News Network, least busted name in news. And may that solar wind be at your back. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.